I am Anil Kumar, and here's solution of question number 6, page 147 from Nelson Calculus, chapter 3.3 on optimization. What are the dimensions of a rectangle with area of 64 meters square and the smallest possible perimeter? Well, you know the answer. The answer is you're looking for a square, right? That is your answer. But let us prove that. So these questions really help you to confirm what you already know, right? So what you are given here is that area is equals to 64 meters square, and you need to find smallest perimeter, right? That is what you need to find. So from the given situation, you can define your variables. Let us say length and width are the two dimensions of the rectangle whose area is 64 meters square. So we can relate these dimensions. We can say, well, area is 64, but area is also equals to length times width. So we know length times width is 64. So now we can say width is equals to 64 over length. So that relates one variable to the other. So we say width is equals to 64 over L, right? Since we need to find the minimum perimeter, we'll write expression for perimeter, which will be 2 times length plus width, right? Now in this particular case, let's open this bracket. So it is 2 times length plus 2 times width, right? So we have 2 times length plus width. We can write in terms of length. So we get just 2 times 64 over length, right? So we get an expression for perimeter here. So perimeter as a function of length is 2 times length plus, we can multiply this, 128 over L. Now as we had been doing, we will find the critical number. So next step is always to find the critical number, right? So let's find the critical number. Critical number is when the derivative is equals to 0, right? So derivative for this function is, so its derivative will be equals to 2 minus 128 over L square, right? So that is the derivative. Equating this to 0, we say 0 equals to 2 minus 128 L square. That means 2 times L square is equals to 128, or L is equals to 128 divided by 2 square root, right? So that gives you square root of 64, correct? And that is indeed 8. So length is 8 for us, and if length is 8, we can calculate the width also. Width is equals to 64 over 8, which is also 8, right? And now we can write down our answer, and that is that for smallest possible perimeter, so we have perimeter equals to 2 times 8 plus 8, which is 16 times 2, 32. What we need to write here is what are the dimensions for the perimeter, and so the dimensions will be 8 meters by 8 meters, right? So 8 meters by 8 meters becomes the dimensions for the minimum perimeter in the given scenario, right? I hope that helps. Thank you and all the best.